is pH anyway? Well, pH is kind of like the measurement of how acidic or basic something is. It's measured on a scale of 0 to 14. The lower the number, down at 0 is the lowest, the more acidic a substance is. The higher the number, up to 14, the more alkaline or basic a substance is. And 7, right in the middle, means that it is a neutral substance. Here's a quick little video that will help you understand a little bit more about pH.
The 17th century English chemist Robert Boyle was the first to study acids and bases in a systematic way. Boyle found that these two types of compounds counteract each other. Acids react with bases so that the properties of both are lost to form water and a salt. This process is called neutralization. Boyle's observations were an important advance, but he could not explain why these reactions were happening. It was not until the late 19th century that a Swedish chemist, Svante Arrhenius, made the first steps to unravel this mystery. Arrhenius found that water often could dissolve both acids and bases by separating them into individual ions. For example, hydrochloric acid, HCl, separates in water. What has happened in this reaction is that the original molecule, made up of one atom of hydrogen and one atom of chlorine, dissociates in water into its constituent H+ and Cl- ions. The hydrogen has become a positively charged ion, or cation, while the chlorine has become a negatively charged ion, or anion. Hydrogen has only one proton and one electron, so a positive hydrogen ion is one simple proton. Arrhenius found a similar process works when bases are dissolved in water, but rather than releasing a positive hydrogen ion, it generates hydroxide ions, OH-. For example, when sodium hydroxide, NaOH, is dissolved in water, this is the reaction. In water, the sodium hydroxide dissociates. The sodium, Na, becomes a positive ion because its electron has gone to hydroxide, OH-, which is a negative ion. Arrhenius summarized his findings by defining acids as substances that release hydrogen ions, H+, when dissolved in water, and bases are substances that generate hydroxide ions, OH-, when dissolved in water. This definition explained a number of things. It showed that acids have similar properties and bases have similar properties. It solved the mystery as to why acids and bases neutralize each other. When these two substances are mixed together, the H+ from the acid mixes with the OH- from the base to produce H2O, water. Arrhenius was also able to show that in the neutralization process, when an acid and a base are combined, they produce water and a salt. The general equation is acid plus base produces water plus salt. For example, when hydrochloric acid is combined with sodium hydroxide, a base, it produces water and an ionic compound called a salt. We think of salt as table salt that we put on food, but there are many different salts, all of them ionic compounds.
Well, that all makes sense, but why is it written as lowercase p, capital H? Well, there's definitely a reason for that. The P represents the inverse log, and the H represents the concentration of hydrogen ions in solution, as you just saw. So really, what pH is a measure of the concentration of hydrogen ions. So the lower on the pH scale you go, the more concentration of hydrogen ions there are. Down to 0 is the highest concentration of hydrogen ions. The higher you go, the higher the concentration of OH- ions. OH- binds with H+, so it reduces the concentration of hydrogen ions. Therefore, it's going to be a different pH level. Right in the middle, at 7, you've got equal concentration of hydrogen and hydroxide ions because pure water, which is a mixture of hydrogen and hydroxide, is neutral. For many people, it doesn't seem to make sense why lower numbers equal higher concentrations of hydrogen ions. Why is an acid a lower number when that means a higher concentration? Well, that's because we're dealing with inverse exponents here, negative exponents. For instance, if I have something with a pH of 2, that pH of 2 translates to the actual concentration of 1 times 10 to the minus 2 moles per liter of hydrogen ions. The number means the negative exponent. And when you have negative exponents, you actually move the decimal place to the left instead of to the right. So the actual decimal number for this would be 0.001 moles per liter of hydrogen ions. Moles is a unit of concentration. On the other hand, if I had something with a pH of 5, that would translate to 1 times 10 to the minus 5 moles per liter because that 5 on the pH scale means negative 5 exponent, which translates to the decimal equivalent of 0.00001 moles per liter of hydrogen ions. Which one of those two is a bigger number? The top. This represents a higher concentration because it's a larger numeric value than this number does. So the higher the numbers go on the pH scale, the lower the actual concentration of hydrogen ions. The lower the numbers, the higher the concentration of hydrogen ions. The other question is, why does it start at 0 and end at 14? Well, it starts at 0 because a pH of 0 is equivalent to 1 times 10 to the 0 power moles per liter. 1 times 10 to the 0 is equal to 1.0 moles per liter, so this is basically 100% hydrogen ions. The scale ends at 14 because a pH of 14 equates to 1 times 10 to the minus 14 moles per liter of hydrogen ions, which in decimal form is 0.000, 13 zeros and a 1 moles per liter. Scientists determined that once you get a smaller concentration than that, you can't actually find any hydrogen ions even if you try to go look for them. So that's the lowest possible concentration they could measure, and that's why the pH level stops at 14. Well, that's all well and good. Now we understand what pH is and kind of how it works, but why do we care? Why is it so important that we study pH in biology? The reason is because everything that happens in your body, from digesting your food to thinking to moving, everything happens because there are chemical reactions between different chemicals called biochemical reactions inside your body that make those things happen. And if the pH gets outside of what its normal accepted range is, those biochemical reactions stop and they shut down. In a couple of units you'll learn exactly why. Now you need to just memorize. The pH is important because if the biochemical reactions will shut down if the pH gets outside its normal range. Next step, we need to learn how to test for pH, and that's what we're going to do in our next lab.